let's talk about something that's hiding inside literally every piece of tech you own. It's one of the most critical components in all of electronics, but, it's also one of the most misunderstood. So today, we're going to uncover the truth about the capacitor. And I'm not exaggerating. That smartphone in your hand, the laptop you're working on, even the most massive, complex systems you can think of. This little guy is in there, doing its job. Modern electronics just wouldn't work without it. Simple as that. Now, you've probably heard a definition somewhere, maybe in a physics class or seen it on a diagram. But what if I told you that the explanation everyone gives is dangerously incomplete? Yeah, that's what we're here to fix. So, let's start with the story you've probably been told. It's the reason why capacitors are so often overlooked and why people miss just how powerful they really are. This right here, this is the official line, the textbook definition. A capacitor is just a tiny temporary battery. And look, that's not wrong exactly. It's just nowhere near the whole picture. Saying a capacitor just stores energy is like saying a Formula One driver just turns the steering wheel. You're missing all the nuance, the control, the real power. And it's that incomplete story that stops us from seeing its true genius. So to get to the real truth, we need a better way to think about this. So let's do this. Forget electricity for a second. Instead, I want you to picture a water tank. It's a super simple analogy, but trust me, it is going to unlock everything for us. First up, let's talk about voltage. In an electrical circuit, voltage is kind of like the pressure that pushes everything along. In our analogy, it's literally water pressure. The more water you have in the tank, the higher the pressure is at the bottom. Makes sense, right? Okay, next up, electric charge. That's the actual stuff that we're storing. In our tank, well, that's just the amount of water. More charge in the capacitor is exactly like having more water in the tank. Easy. And here's where it all clicks together. Capacitance. A capacitor's capacitance is basically just the size of the tank. A wider, bigger tank can hold way more water for the same amount of pressure, and a capacitor with a larger capacitance can hold way more charge at the exact same voltage. Okay, so now that we've got that water tank analogy in our heads, we can finally talk about what a capacitor really does. See, it's not just a passive little storage box. It is an active controller of energy. Its real job is so much cooler than just sitting there holding a charge. So if we could zoom all the way in, this is what's physically going on. You've got two metal plates, and they're separated by an insulator. When you apply voltage, charge starts to build up on the plates, creating this powerful electric field. And this is the key thing to remember. The charge doesn't flow through it, it piles up on it. And because of that unique structure, it can do all these amazing things. It can soak up any voltage spikes and then fill in the dips to give you a nice, smooth power supply. It can block certain kinds of current while letting others pass right through, which makes it an amazing filter. And yeah, it can charge up nice and slow and then bam, release all of that energy in one massive, instantaneous burst. And of course, it's not a one-size-fits-all kind of deal. Just like a mechanic has a whole toolbox of different wrenches, engineers have all these different types of capacitors. You've got ceramic ones, electrolytic ones, film ones, and each one is built with specific properties for a very specific job. Okay, theory is great. Analogies are super helpful. But now it's time to see the raw power we've been talking about. Let's make this thing real. So we're going to take this high-voltage capacitor and pump it all the way up to 400 volts. All of that energy is now just sitting there, right between those two plates, stored up in an electric field, and it is just waiting for a path to get out. So here's the plan. We've charged it up, building all that potential. Then we're going to close the circuit, which gives all that stored energy a place to go, and believe me, it will go instantly. All of that charge is going to rush out at once, releasing its energy in a brilliant flash and a pretty loud crack. And that is the real story of the capacitor. It's not just about storing, it's this whole process. It carefully gathers energy, it holds onto it with incredible precision, and then it unleashes it on command, exactly when and how the circuit needs it to. So what's the big takeaway from all this? Yes, okay, a capacitor stores charge. But by doing that, it's actively controlling voltage. It's shaping the signals that are flowing through a circuit. It's a regulator, a filter, and a high-speed power delivery system all wrapped up in one tiny package. So the next time you're looking at a circuit board, don't just see a tiny little can. See what it really is, a sophisticated manager of energy, just waiting for a job to do. The only question left is, what are you going to build with it?